Hello everyone, this is something I had meant to do early in the week. I'm going to put it out here, and it's to go through a quick review of the stuff we talked about in class this week regarding GIS vis-a-vis Civil 3D. First off, things I pointed out was this concept of ubiquitous positioning and computing. And you're going to see this word ubiquitous is going to come at you again in a little blurb from Wolfram Alpha. Okay, everywhere, omnipresent, everywhere. All right, so GIS, you have to realize the big player is called Esri, and they do a product at this point is probably called ArcGIS or Arc something, ArcView, and it is on the computer. So one thing I've noticed on our computers, it's got a great seamless topo map of the entire US. So Esri, and then you have over here from the other reading Autodesk. Now Autodesk, they build their engine on something called AutoCAD Map 3D, and this of course is built on this basically ArcView or ArcGIS engine. AutoCAD traditionally has been a vector, but now it is both vector and raster, and this as well as both vector and raster. All right. This is what GIS professionals tend to use. And over here, AutoCAD and its products are kind of the engineering professionals. This is traditionally used something called shape files. We'll start to see those. And this is used some other form, typically AutoCAD, DWG files. The reality is they each will read each other's files now. So realizing that a lot of what you've been learning especially in the survey portion of the Civil 3D, has to do with polygons. And so that's what we're going to talk about in terms of the theory here of GIS and how the basic math and science of GIS is something called topology, which is the study of adjacency and inclusion. So I'm inside of you, I'm next to you. So I'm going to go here and just go through, within these 15 minutes, the theory of how the accounting works in a GIS program and how you'll see Civil 3D is a little bit not quite there. So here is, I'm going to sketch up right now a parcel map basically, and we'll talk about what's here. So I'm going to go at something there, something there. Give a curve to this one from there to there. I'm going to give a curve from that one from there to there. I'm going to put points now at all of the basic nodes, if you would, in a system that's a GIS system, and you're going to see the difference here. So make that a line here, and that's a line. And maybe I'll just do one more odd. Right. And what you'll see is, in fact, the topology does not deal with the geometry. It deals with just in a different way. It lets the geometry deal with itself, so in other words, where these things are. But in terms of inclusion and adjacency, it deals with it in a data structure. So the key points within a GIS system are you're keeping track of points, lines, or arcs. And arcs are going to be lines with bulges. Polygons And then eventually we didn't talk about it, but paths. Polygons and then paths. And basically, if you kind of keep track of everything in accounting by these ways, if you move one thing or the other or remove one or the other, the accounting becomes pretty easy. So what I'm going to do is start here with the points. Start here with points, and then polygons, and then eventually path. So in the middle there, of course, we have lines. And I'm going to go ahead and number and then name. So I'm going to go this number 1, 2, 3, 4, 5, 6, 7, 8, 9. And you see there's no 10 here because this is just the basic bulge. Now I could be wrong on that. I'm going to give these now letters. And I'm going to call that, and I'm going to give them direction as well. This is from 1 to 2, 2 to 3. And you'll see later on, you always, typically, if you don't have an otherwise reason, you're going to number up. So 1's going to go to 4, 2's going to go to 5, 3's going to go to 6, 5 will go to 6. And it doesn't work this way all the time, but when you get into structural numbering in the lever, you kind of number from lower node to upper node. So you've got here more or less a link node type diagram. You're going to see it again, and then 8 goes to 9, 7 goes to 8, and then 7 goes to, all right? So I'm going to give these letters. This is going to be A, B, C, D, E, F, G, H, I, J, K, L, and then M. And if you think about it, we can number our points 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then each of our lines, A, B, C, D, E, F, G, H, I, etc., are going to go from one to the other. The lines or the paths are each basically links. And I'm gonna forget the typical primitive word for it. Basically, we're talking here, another word for these things are primitives. But it's probably more if you get into 3D shape stuff. All right, so line A does not go from 2 to 1, it goes from 1 to 2. And line B goes from 2 to 3. And line C goes from 1 to 4. All right. So these are the points. These are the lines, and these are the points. Now, finally, I'm going to change colors to give us names to these polygons. And then we'll come back and talk about the idea, concept of bulges here. So I'm going to give this, I said in class, a cougar, a lion, a gazelle, an ostrich, and I'm going to call this a zebra. Now, if you think about it, I don't know if this is a good place, but the lion's going to eat them all, so it doesn't make any difference. He's going to jump the fence. And so this concept of parcels, if you would, is what you would have dealt with in the past. How does it keep track of cougar? Well, if we go now to the parcels, cougar is right of line A, so it's, I guess, lines. It's positive from A. It is positive from D, or right of D. It is negative of F, and it is negative of C. In other words, you keep track of cougar by on which side of any particular line. You keep track of lion. I'm going to do lion here. Lion is, I'm going to go, it's not involved at all in A, but in B. It is B. It is negative of B. I'm sorry, positive B, because you're going in a positive direction like you do in stations, and you're going to be on the right side. Lion is positive of B. it is negative of D, it is negative of G, and it is positive of E. And so right in this, you can see that by the data structure, it could tell that the data structure would know that line is next to cougar, and there's all kinds of ramifications that come up from that. So, and why does that influence? Well, the data structure becomes pretty easy. If I all of a sudden have to move 0.5 over to here, which would shift this line here and this one here, the only data point I've got to do is right here. I've got to change its coordinates there. Okay, the last thing I want to point out I didn't talk about in class is this, is how do you go about labeling these, or how do you go about making these things? Basically, the term would be tagging or centroids. So basically, once you've done all of your lines and arcs and a letter, you would come up with what would be called centroid points, is how you usually keep it. You keep track of centroids by polygons, right? And there could be some later problems if you move the edge of these too far, but for the most part, if you kind of tell the program that zebra is kind of centered around here, there, it'll kind of figure out and keep track of the centroid. So polygons are kind of tagged by centroids. Though you'll often see cities, when we start doing mapping these things, we're going to very often put another tag up near the front, which is a frontage tag. And that can be convenient or not, but the reality is really it's the centroidal tags, which have to do with a lot of when you're dealing with, for instance, buffering and whatever. Because the final thing within the 3 minutes, how is GIS? How does it correspond to civil and everything else? Well, for instance, let's say here you're going to go ahead and put in a water well here. According to code and a wellhead protection district, there is a certain buffer around that water well that certain things should not occur on. Sometimes another one would be, for instance, let's say from when it comes to planning, the sex offender list. If a sex offender lives in a particular home, you know, he has to live so many feet from from schools or whatever else, or all kinds of different ramifications. But this stuff has all become much more possible due to GIS. In reality, we are building infrastructure, and infrastructure has very much complexity in it. Infrastructure, right? So if you've got basically these land decisions, and land is money, all of a sudden you've got both engineering and planning, basically. All right, so this use, you'll see, I'll be pointing out where the holes are as you go through the semester within Civil 3D when it comes to this GIS aspect. But get used to it now. You've got a while here. You got a whole 2 semesters, and we've got some in-house expertise. I think Kaylee's got some expertise, and a number of you others as well, whether or not you realize it or not. This concept of looking at how AutoCAD map works with, or conceptually works with, GIS underneath Civil 3D is very important. And that pretty much comes from starting, if you remember, on your coordinate system. Because if you have not set up your coordinate system, you cannot easily share data back and forth. And so there's, you know, about 1 million readings you can do on this, but for now, we're just going to try to think about this again, the fact that points, lines with bulges if they're arcs, though civil, we don't do it that way, and then polygons, and then finally paths can be open or closed. A polygon is a closed path, but it basically, in turn, when you get into routing, which is a lot of what civil uses this for, you have a number of different paths to get from 1 to 9. You could go that way, you can go that way, you could actually go this way, right? All kinds of different paths, and that's essentially where we really get into GIS. Thanks for listening, and I will make you actually click that you would watch this or we're in class. Thanks for listening.